project is an ecosystem exhibit that can be on display at a science center. It highlights several biotic and abiotic factors of a forest ecosystem and demonstrates key ecosystem functions.
This is a flowchart of how our project works.
To start, the user says, "Alexa, trigger the ecosystem exhibit."
We programmed Alexa so that when this specific phrase is said, it performs two main actions. First, it begins playing nature sounds through the speaker. Secondly, it triggers another software called IFTTT to call a code function on our internet-connected Photon microcontroller. When IFTTT calls the function, it passes the string start as a parameter. When the Photon receives this, it activates and begins executing code, which causes it to perform four main actions simultaneously. First, the Photon controls this servo motor.
This servo motor moves 90 degrees to this limit switch sensor, which serves as a start button to both pneumatic fluid power circuits.
Our first circuit uses control relays, limit switches, DCVs, and pneumatic cylinders to create a reciprocation circuit that causes the cylinder to repeatedly extend and retract. This controls our cabling system, which moves the fish's tail.
Our second circuit also uses a reciprocation circuit to move the turtle up and down as our second movement.
We used a dummy cylinder to control the movement of the cylinder that is used with the turtle, so we didn't have to mount limit switches on the top of our project. The second thing the Photon does is send an electrical signal to an Arduino microcontroller.
Once this microcontroller receives a signal, it controls this servo used with the bear.
The bear moves through the use of an interior skeleton, which is attached to the servo motor.
This is our third movement.
The third thing the Photon does is send another electrical signal to a second Arduino microcontroller.
When this microcontroller receives the signal, it controls both strands of lights, which move in a wave-like pattern.
Lastly, the Photon sends another electrical signal to a third Arduino microcontroller. After this microcontroller receives the signal, it controls this DC motor. The motor controls two sprockets that have a chain attached and cause the frogs to move across the underwater portion of our project. This is our fourth movement.
Here's our project working all together. Alexa, trigger ecosystem exhibit.
We made many iterations to our design as we completed the project. Originally, we planned to have two of our movements incorporate the bear by moving its head and arms. We decided to change this because we wanted to incorporate more things like the turtle and frog into the project.
We also worked to make our project more interactive. As the project runs, the user can read the information cards and ask Alexa to tell them more about a specific component in the project. For example, Alexa, tell me more about frogs.
The frogs moving across the underwater portion of the exhibit serve as an indicator species for the ecosystem. Indicator species are sensitive to environmental changes such as pollution. Therefore, their health indicates the health of the ecosystem.
We also faced many problems throughout the completion of our project. One was with the electrical circuits used to control our fluid power systems. We designed our circuit correctly, but read the relay diagram wrong and ended up wiring the circuit incorrectly. Once we realized our mistake, we were able to quickly fix our problems and it worked perfectly.
The biggest problem we faced was with communication. Our school is operating in a hybrid environment with half the students coming in on Monday, Tuesday, and the other half coming in on Thursday, Friday. As a result, we were unable to meet with our entire team, so we had to communicate via text message, email, and Zoom meetings. Overall, this improved our communication and leadership skills, and we were able to finish our project successfully and on time.